OACB is a parallelogram with OA vector is A vector and OB vector is B vector, where A vector and B vector are non-zero vectors. Shows that OC vector magnitude squared is equal to a given expression. So it is given a parallelogram, and it's very important to keep a given order of letters. So it must be O, A, C, B, and it is given that OA vector is A vector, and we can see that BC is also BC vector is also A vector. It is given that OB vector is B vector, and we can see that AC vector is also B vector, and we need OC vector magnitude and square. And let's consider what is OC vector. We can see that OC vector is just A vector plus B vector, because we can apply a triangle rule for the sum, or parallelogram rule for the sum, and we can see that it's OA plus AC, which is A plus B. But question is, what is OC vector magnitude and squared? We know a formula for the dot product of two vectors, for example V vector and W vector dot product, and it is equal to magnitude of the first vector multiplied by the magnitude of the second vector and multiplied by the cosine of the angle between them. And if we consider two equal vectors, we can see that it is equal to magnitude multiplied by the same magnitude of a given vector and multiplied by the cosine of 0 degrees, because if we consider two equal vectors, or two the same actually vectors, angle between them is 0 degrees, and cosine of 0 it's 1. Hence we can see that, and it's magnitude squared. So we can see that magnitude of a vector squared can be represented as dot product. So OC vector magnitude squared can be represented as OC vector dot product OC vector, and hence we can get expression in terms of A and B vectors. So we can write the next that it's OC vector dot product OC vector, and hence we get that it becomes A plus B dot product A plus B. And similarly to usual multiplication, we can expand it, but instead of just multiplied, we use dot product. So it becomes A vector dot product A vector plus B vector dot product A vector plus A vector dot product B vector plus B vector dot product B vector. And again, dot product of two equal vectors is just magnitude of A multiplied by magnitude of A, which is magnitude of A squared multiplied by the cosine of the angle between them, which is 0 degrees, and cosine is 1, so it's just magnitude of A squared plus dot product B dot product A is the same as A dot product B, so it's plus 2A dot product B plus B dot product B, just magnitude of B vector squared. And we get a result as required. And the next, we need AB vector, and then AB vector magnitude squared. So what is AB vector? AB vector, we can use directly a rule for the difference of two vectors. It's directly B vector minus A vector, or you may use a triangle rule for the sum. It's AO plus OB, and AO it's minus OA, so it's negative A vector plus B vector, which is B minus A, and hence AB, similarly AB vector magnitude squared, it's AB vector dot product AB vector, and it's B vector minus A vector dot product B vector minus A vector, and expand it to get B vector dot product b vector minus a vector dot product b vector minus b vector dot product a vector minus, or not minus, plus a vector dot product a vector, and it is equal to a vector magnitude squared minus 2a vector dot product b vector plus b vector magnitude squared as required. And the next, given that OC vector magnitude, just magnitude, is equal to AB vector magnitude, prove that OACB is a rectangle. Since OC vector magnitude is just its length, so if the length of one vector is equal to the length of another vector, hence squares or lengths squared also will be equal, so we can write that OC vector magnitude squared will be equal to AB vector magnitude squared, and we can equate the obtained result, so it becomes A vector magnitude squared plus 2A dot product B plus B magnitude squared is equal to A vector magnitude squared minus 2A dot product B plus B vector magnitude squared, and we can see that this is equal to this, and move to one side, we get the next. For A dot product B is equal to 0, since A vector and B vector are non-zero vectors. It means that A dot product B is equal to 0, and dot product is magnitude of A multiplied by magnitude of B multiplied by the cosine of the angle between them. Hence, cosine of the angle between them is 90 degrees. Hence, A vector is perpendicular to B vector, and therefore OA is perpendicular to OB. OA is perpendicular to OB, and it means that sides are perpendicular, and hence a given parallelogram is a rectangle as required. So OACB is a rectangle as required. And that's all for this question.